Hi guys, Dr. B here. This lecture is average atomic mass, isotopes, and relative abundance. So important vocabulary for us when we're talking about average atomic mass. The atomic mass is the mass of an atom and is obtained by finding the average mass of isotopes of a given element. An isotope for the same atom, in the sense it's the same thing, like carbon, for example. Different isotopes, so they have to have if they're all carbons, they have to have the same number of protons but different number of neutrons. The relative abundance is the relative abundance of an isotope is the percentage of atoms with a specific atomic mass found in a naturally occurring sample of an element. Isotope notation. So you list the number of an element after its name or element symbol. For example, an isotope with 6 protons and 6 neutrons is carbon-12 or C12. An isotope with 6 protons and 7 neutrons is carbon-13 or C13. Sorry. This should be C13. Note that the mass number of two isotopes may be the same even though they are different elements. For example, you can have carbon-14 and nitrogen-14. The mass number may be given in the upper left side of an element symbol. Technically, the mass number should be stacked in line with the mass number and the atomic number, should be stacked in line with each other, but they don't always line up on a computer. For example, the isotopes of hydrogen may be written as the following. The number on top for each of those elements which of those hydrogens is the mass number, and it's all ones on the bottom because these are all considered hydrogens. Let's look at the following. So we have carbon-12, 13, and 14, atomic numbers, protons, electrons, mass number, etc. So again, how are these notations going to be alike? How are they going to be different? So we said carbon-12, 13, and 14. So they are alike because they have the same number of protons and electrons, and they're different because they all have different mass and different number of neutrons. So same protons and electrons, that's how they're alike, and they are different because they have different mass numbers and different number of neutrons.